What's up everyone, and welcome back to another Vedic mathematics video. So, just as a disclaimer, we will be programming it, so there is Python. You don't have to skip it just because it's mathematics. Alright, let's get that out of the way. So, yes, this is the second video, and let's just get right into it. So this is the Nikhilam Navatascaramam Dastah. It's a sutra in Vedic mathematics, and it literally means all from 9 and last from 10. Of course, we got this straight from Swamiji's book, which we will be using to refer to for the rest of the series. Okay, so let's discuss when to use the sutra. The sutra helps you multiply any set of numbers very easily. So here we have some examples: 4-digit, 3-digit, and 2-digit. Alright, so let's go over the parts again, because this sutra is pretty large, so I divided it up into 4 videos. The first video was numbers close to the base. The second one is the numbers above the base. The third one, we're going to be mixing both of them. And then in the fourth one, we're going to be discussing in between the base. So we did number 1. I would like to welcome you to video number 2. Okay, so let's just get right into it. We have 12 times 13, and I know you know the answer, but we're just gonna do it the Vedic math way. So in the future, you're gonna have a much easier way to solve it. Okay, so first we have to calculate the base. So that is going to be the closest multiple of 10, but it has to be less than equal to the numbers. So in this case we have 12 and 13, and we're going to get the closest multiple of 10, which is less than equal to the numbers, which is going to be 10. Okay, so we set up 12 and 13 over there, and that's our left section, and the one to the right is the right section. So we're going to find the first number in the right section, or column. So right one is going to be equal to left one minus the base, which is going to be 12 minus 10, which is going to equal to 2. So we can add 2 there. And then right 2 is going to be the same thing, so 13 minus 10, just the lower one. That's going to be 3. And notice how we're adding this time. Last video we subtracted. So now we can set up our bars, and we're going to multiply 2 times 3, which is 6. And then now we have a couple ways to get the first portion of the answer. So one way is we could do 12 plus 13 minus 10, which is both of the left parts minus the base. Or we could add the base and the right column numbers. Or we could cross add, so 12 plus 3, or converse 13 plus 2. And all of them are equal to 15. So you could choose whatever you want. So the answer is going to be 156. Cool. We can put that in there. And now let's discuss some larger numbers. So 1005 times 1003. We have our base, which is going to be the closest multiple of 10, less than or equal to the numbers, which is 1000. So we can quickly get this set up. We know it's plus 5 and plus 3 left and right. So we're going to multiply 5 times 3, 15. But there's a catch. Since the number of zeros in our base is 3, we need 3 digits on the right side. So whatever the number of zeros is in the base, that's the number of digits we have on the right side. So we need to add a 0 in front of 15 because we can't just add it to the right. We need to add it to the left. And then, of course, 1005 plus 3 is the way I like to do it, and we get 1008. All right. Now, let's do carrying. I gave that away, but that's okay. 15 times 15. Set it up with, well, we get the base first, which is 10. Now we set it up, and we can quickly do 5 times 5 is 25. But as you can see, we have 25, there's only 1 0, and we have 2 digits in the right. So first let's solve left, we get 20. Now we can deal with this. So we subtract 2, which is the first digit, and then we add it to the left side. So in the end, we get 22 and 5, so the answer is 225. Oh, and the previous answer was 1,008,015. In case forgot to say that. So those are the 3 scenarios: carrying, adding a 0, and the normal go-to way. Alright, so let's discuss limitations, which we had to come up ourselves, since they're not very clear in the book. So number 1 is both multiplicand must have the same first digit. So these won't work. None of them work. Number 2, both multiplicands are the same length. So They both have to be the same length in order for this to work, and later we will get to non-same lengths, hopefully. So we'll see about that. Alright, so let's just get started by defining our main function that takes num1 and num2. After that, we can create our base 1, which is going to be equal to the integer of 1 plus, just bear with me here, it's kind of complex, and I'll explain it after. It'll just be easier that way. Okay, so over here we have our base 1 calculated, and what is going on is we get the length of our number. This should be in parentheses. So we get the length of our number, and for that we need to convert the number to a string, because you can't take the length of an integer, only strings and stuff. So we get that, and then we subtract 1, because 1 is already being added here, we only want the zeros. And then we use this multiplication operator to multiply this string by that number, which basically, if this is equal to 2, we multiplied by the 0 string, we get 2 zeros in a string. So we do that, and then we add string 1, and we convert all of it into an integer. So that's how we can get our base 1. Now we just have to do base 2 the same way. Okay, so now we have base 2 calculated. Now we're going to need our zeros. If you remember or recall, we did talk about needing zeros. So we can just copy and paste that in. And there you go. Those are our 3 initial variables. After that, we can go straight to our first priority conditions. So we have 4 of them. Number 1 is if the numbers are not the same length, then the formula is not applicable. Number 2, if any number is equal to 0, return 0. Number 3, if any number is equal to 1, return the other number. And number 4, if both numbers are less than or equal to 5, then we can use the multiplication table. Because SwamiG expects you to know 5 times 5, not 12 times 12 for the multiplication table. So we can hard code that into our program. But we're going to do that at the end. Let's just do this first. So our first condition was checking the length. So if not, the length of string of num1 is equal to the length of string of num2. So if that happens, if they're not the same, then we can return formula not applicable. I'm going to copy this string. We'll leave it there actually. Okay, so now we need if num1 is equal to 0 or num2 is equal to 0, we return 0. Because anything times 0 is 0. Next, if num1 is equal to 1, then we can return num2. Else, if num2 is equal to 1, then we can return num1. Cool. It's complaining that I have a white space trailing. Okay. Now I can take out my multiplication table, which is hard-coded from 0 to 5, and it's essentially just an array. Cool. So we need that because we're going to do if num1 is less than or equal to 5 and num2 is less than or equal to 5, then we're going to need to return the multiple table, which takes sub1 and sub2 of sub1. Because it's just an array, we can easily do that. Cool. So now that all of that is done, we can actually begin solving the Vedic math protocol. So we're going to first get right 1, which is the num1 minus the base 1. Then we can get right 2, which is num2 minus base 2. And then we need to get our left answer and right answer. So left answer is going to be equal to num1 plus right 2. You could use any of the 4 methods I showed you. You can go back into the video and get them, but I'll have them on the screen right now. I'm using the cross addition. Okay, and then we have right answer, which is going to be equal to the main, and this is main, so we're using recursion of right 1 and right 2. So we're going to call this function again and get that. But if you noticed, we do return formula not applicable. which means right one, or the right answer can end up being formula not applicable. So let's deal with that too. So right answer is equal to formula not applicable. I copied the whole thing. Then we can return formula not applicable. Cool. Now let's get carrying. So we discussed about carrying, we can implement that now. So if the right answer is greater than equal to base 1, and right now we're just using base 1, base 2, we're just using one base for now. We can create our toCarry variable, which is going to be equal to the string of right answer. This gets complicated because we're going to take the sub, we're also going to splice it at the same time. So essentially what this is doing is, hold on, I'll explain after. Okay. So what this is doing is taking all from the beginning, all the characters necessary to make the length of the answer proper to the zero. So in other terms, if our answer has 4 digits and our base only has 2 zeros, it's going to take out the first 2 and make sure that there are only 2 left. So it's kind of like that, and it's takes out whatever. It's not just taking out the first digit. And then of course we can get our left answer, which is just adding integer of toCarry. Now we have to modify right answer, so we can make it equal to this. So I'm just going to copy that. It's the same exact thing, just put the colon at the end. So now we're taking out the first 2 and modifying right answer, and before we were taking out all the rest. So you can just do that. Alright, now we need to add extra zeros in front of right answer if necessary. So we can use a while loop for that. So if while length of string of right answer, lots of modifications to right answer, is less than zeros, then we say right answer is equal to 0 plus string of right answer. So in the end, right answer is a string, and so is left answer. So we can return a converted integer of the joined left answer plus string of right answer. Okay, there you go. So we did all of that. Now we have to test it. So I have test code over here. It will also be in my GitHub, so you can grab it for yourself. Just copy all of that and paste it in here. So we could do some manual testing. Let's go ahead and start with one manual test. We could do 24 and 25. So this is going to first get the answer, then it's going to print it, and then tell you if it's correct compared to Python's multiplication operator. And if there's a recursion error, then it's going to print error. Let's go ahead and run that. Alright, we get 600, and yes, that's correct. Great. Now we can go ahead and do an exhaustive test. So I'm going to close the terminals here, and we're going to comment this out. We can uncomment our exhaustive check, and this is going to check, so 10 times 10 is going to check 100 equations, and we're going to see how many are correct. So if the formula is not applicable, it's going to pass. If the answer is not correct, then it's going to print not equal. And then otherwise, if it's correct, we're going to get a count. Recursion error is going to print error. And in the end, we're going to see how many equations it solved. So now we can run that. 100 out of 100 equations solved. Very nice. It's much better than our previous sutra or previous answers. And I will present the graph after we get some more data here. We can increase it to 100. So this is going to be 10,000, and we have 1,000 equations solved. Now we increase to 1,000. This might take some time here. 1 million equations. Anytime now. And we get 10,000 equations solved. So here you can see the graph, what we have right now. So you can see the graph here, and we started off with 100% very solid, awesome work. And then we came down to 10%, which is much better than the previous graph, previous answers, I should say, which we only solved 4%, 5% out of the 10,000 equations, and this time we solved 10%. And then we had 1 million equations, which we only solved 0.5%, this time we solved 1%. So big improvement here, almost twice as good in all the areas. So I would call this a big success, and as we stack them together, so we're using both sutras at the same time, then we can really see a lot more improvement. And we still have 2 more sections to go, so who knows what that will change. Alright, so hopefully as we stack things up, we're going to get very high performance and create a very efficient multiplication function. That's basically everything, so I'll see you in the next one.